Hi, Bernhard.
Hi, Carsten. So what are we up to in this episode?
After a very long first introduction video, this one will also be a bit theoretically, but it's
Yeah.
very important. We're talking about networking in a stretched Azure Stack HCI cluster. And
Mhm.
please watch the video because
I
we
think it's one,
explain a lot,
yeah,
because we
one of the
explain a lot
most
of difficult
important.
things. It's
Yes,
most important. Yeah.
it's
So
one of
let's
the
me.
most important things. Yes.
Yeah.
So if you could switch to my screen, and I'll take over the first slide. Yes. So we do have in a Azure Stack HCI environment quite some networks to care about, right? So we have the management network for the cluster to domain controller communication, the virtual machine network, the compute network, how it is called on our websites, and then the storage networks. And then also some additional networks, especially dedicated or that are special to a stretched cluster environment. And that's, sort of what we are covering in that video. So, but, let's start with the network definition. Where does that come from? So let me just point it out. There is a link to this, and I will post this link in the video series. This is basically the starting point for the host networking, right? So you see here the traffic classes, which I was talking about, the management one, the virtual machine traffic, and the storage traffic. Um, and it explains, a little bit about that, and you may, want to read that through. Um, so let's maybe go through them shortly, and I think you are going to cover or talk a little bit about these different traffic classes, right?
I do. So I switch to my screen.
Mhm.
And now we talk first about the management network. What's the purpose of the management network? It's an external facing network, so we can access over it the core infrastructure. For example, as of September 2023, an Azure Stack HCI cluster requires a local Active Directory. So it has to be part of an Active Directory. We also have maybe DNS servers. Yeah? Management, if you want to do something on the cluster with failover cluster manager, with Windows Admin Center, with virtual machine manager, with PowerShell, you use this network because usually the software is not running on the host itself. It is a core edition. It can't run, for example, MMC plugins.
Mhm.
Remoting, maybe you want to go to the host. Monitoring, Azure Monitoring, for example, is a great solution to monitor um, Azure Stack HCI. We need a witness, especially in a stretched cluster. We talked about that in the last video. Witness is essential. So this is the network over which the witness is reached. In most examples, also backup and updates and so on. We use this
Mhm.
network. Also important, access to Azure, because our Azure Stack HCI cluster has to be connected to Azure for at least billing purposes. We can do more from Azure, Arc and monitoring and everything else, all the good stuff, but at least we need it for billing. So this network has to be also external connected. We have to reach Azure.
Mhm.
This is a stretched cluster, so we need two subnets for our two sides. So we have hosts in one side and we have hosts in the other side, and we have to have a management network, a subnet in side A and a subnet in side B, and that's in the documentation you
Mhm.
showed us briefly, and we will talk more about it. So that's a
Mhm.
requirement that we have two management subnets and do routing between them.
Mhm.
And as a consequence of that, our cluster has two cluster IPs, one in the site one and one in site two. And we will see that later in our video when we play a little bit with our cluster, right?
Mhm.
So
And
then
whoever
this is
has
yeah.
is the owner of the cluster rule, right? The either one or the other IP address is
Yeah, it
active or
one
not.
is only used.
Yeah.
You're right. Where the core cluster resource is presented in which site, we have only one of
Mm.
those. And yeah, you're right. So this is the management constraint, how we call it when we would use network ATC. So
Mhm.
the next logical network is the network we use for our virtual machines, and I call it VM network. You can also call it the compute constraint. Yeah? And
Compute
what is
network,
the
yeah.
purpose of this network? Yeah, our VMs have to connect between each other or even externally. So with the
Mhm.
Active Directory, with uh, Exchange, whatever. So your VMs have to communicate,
Mhm.
um, and this is a network for that. It's
So
quite
as
simple.
well,
Like in every
yeah,
other cluster where you host virtual machines,
yeah.
you have to have
So
a compute network.
regarding the link speeds, right? So I mean, we often see gigabit or 1 gigabit adapters or being used for the management. I mean, if you're not doing backup with it, right? I mean, for most of the stuff, 1 gigabit is enough, probably,
Mhm.
right, for the management. Not for backup, but you might have a bigger bandwidth there. But for the VM one, you see usually what link speeds do you see usually for the compute network?
Yeah, there are some customers who do 1 gigabit, but I
Mm,
would go 10 or 25
yeah,
in a new implementation. Yeah.
yeah, yeah.
And we will do 25 gigabit. Not that
Okay.
we need that, but we will do it. Okay.
Yeah, okay. Next
So
network.
the next network would be the storage constraints. I call it SMB network because it
Mhm,
uses SMB3 as a protocol, and the purpose
mhm,
is in our stretch cluster, we we have two sites, and we have a storage pool in each of those sites, and all the disk of the computers in one side are in the storage pool. But
mhm,
still, we have at least two nodes, maybe three or four in each
mhm,
side. And if we have our storage spread over the different nodes in the site, so we
mhm,
want to use a very high performant storage network for that, and that would be our storage constraint or SMB network. Um,
mhm,
if we do a live migration in a site, so we move one VM to another host in the same site, it would be nice to use this
mhm,
network because it's
mhm,
very powerful, and usually it has RDMA, at least in
mhm,
my implementation. So we
mhm,
want to use that network. And if we have cluster communications and also the heartbeat in the
mhm,
same site, it would also leverage this network. So this network is a multi-purpose network, of course, for our storage traffic, but also I use it for live migration and cluster communication at heartbeat.
okay.
We have two cards in our scenario. So we have two subnets for the
Mhm,
two SMB networks, and these are without routing. So we can only reach over this network host in the same site. And of
mhm,
course, we want to leverage RDMA support. And
mhm,
this is nearly the only network where we can use RDMA support. So let's maybe look at the next one, right? The next one is
mhm,
new. So far, the networks are not new
mhm,
to people who build the cluster, especially an HCI cluster. These are the usual networks. But now comes a new one, a special one that is only present in a stretched Azure Stack HCI cluster, and it's called the Replica Networks. And
mhm,
what is the purpose of the Replica Network? So if we have a volume or a cluster shared volume that is replicated to the other side, not all volumes have to be, but some, of course, will
mhm,
because you have a stretched cluster and you
mhm,
want to use storage replication. This is a network we use for that. It's an
mhm,
inter-site storage replica. So the traffic from site one to site two is should be done over these networks. We
mhm,
need subnets. I usually have two replica networks per site, so in total four of them.
mhm,
I have different subnets, so in total we would have four in our cluster, so two per
mhm,
site.
mhm,
And when we want to use those networks, we have to specify routing here. Yeah?
mhm,
So we can't use a layer two stretched VLAN for the replication network. You will go back to the documentation from Microsoft, and Microsoft said
yeah.
if something leaves a site, we have to use routing, so layer
Mhm,
three. So these networks have to be routed. And we need a very fast gateway because over this network,
Mhm.
every write that is done to a local local volume is also replicated to the other side. And if we use synchronous replication, we have to wait until it's
Mhm.
replicated to the other side and written there, and the acknowledgement comes
Yep.
back. So if you would use a 1 gigabit network, imagine you have NVMEs and then use a 1 gigabit network for the replication, that would be very, very slow. Yeah?
Mhm. Okay.
Unfortunately, Microsoft doesn't support RDMA on these network cards. The traffic is SMB3, so it would be natural to use RDMA here, but it's not supported if if you leave a rack aside. And ideally, that's one of my findings. And also, I had some calls with support. Ideally, no other traffic is using these networks. And
Mhm.
we come to that a little bit later. Yeah. Okay, Bernhard, I
Okay.
think now it's your turn, right?
Yes. No, if you could, switch to my screen.
I
Um,
switched to your screen, of course.
yes. So all of what Carsten just said is, part of the same website which I was driving you before, right? Which is still there is a section right at the lower third of this article, and it's a very lengthy one, but it talks about the stretch cluster setup and what the requirements are, right? So, I mean, it is there. It tries to put in some graphics to explain the things, put out the requirements. For example, the host communication must cross a layer 3 boundary, which means routed, right? That's also applicable for the replication traffic, which also needs to be routed, like Carsten said. What I like is also this graph here, because that's, sort of an explaining how a base setup will look like, right? Um, and it gives you an idea on, sort of how to put the cables at least a little bit, right? And also talks a little bit about the networking underneath. However, would that be enough, in my opinion, to actually build a stretch cluster? Well, it might, but I would love to have a little bit more context and little bit more information, and that's part of this video series, right? And Carsten, I think we are taking it from there, right? Um,
So what's
and
missing here, for example,
mm,
Bernhard, you can do the presentation.
mm,
We didn't have any management
right,
constraint, and
right,
also our VMs are not present. So it's
yeah,
a part of the true story, right? And now,
yeah.
Bernhard, show us the true story so far.
So you have imagine you have the cluster nodes, and this is the names of our nodes in our setup. So we have two sites, an odd site and an even site, right? So you could say see it from the numbers, from the numbering of the hosts. And okay, Carsten, you said we have a management network, and we have two of them, because in each site you need to have an own management network. So look at the IP address range, it's different. Look at the VLAN ID, it's different, right? So we have two of them. The other thing is the storage traffic. You talked about it. It's also, um, for redundancy reason, two lanes or two subnets on each site, right? Also same here, different IP addresses, different VLANs, right? So why? Because you don't want to have your cluster think that it is living on a partitioned network, and that's why we use a different IP address range, right? The other thing is, okay, we do have, and that's what we see most often, right? So the people are not using different IP addresses. I think for most of for the virtual machines, most of them, a sort of a stretched VLAN, as I would say, at least not for the other stuff, but for the compute adapters, or for the virtual machines traffic, right? Um, and then finally, we do have the replication traffic, um, and also this is on both sides, right? So also here, different IP addresses, different subnets, different VLAN IDs, right? Um, Additionally, we do need to think about the routing between, and that's the next slide, which is animating where to route the traffic. So in order to to have a successful cluster that is able to talk to each other, to see the other's nodes, to do the heartbeating, right, you need to route the management traffic. Okay, I think that's pretty obvious, right? Also, same here is in order to transfer data from the odd side to the even side, right, to replicate our storage traffic, this also needs to be routed. This is a high-speed network, right? High-speed gateways, because we don't want to have high latencies on this one, right? So that's the reason, um, or that's something that I would like to point out here. Okay, but so far, and that's sort of consistent with the Microsoft documentation that I was showing. But there is another thing which is which we found out, which is very helpful for adding to the cluster, to a stretch cluster, and that's, I think, Carsten, your point where you're taking over.
Yes, I will take over. And there is one more thing, because the network design so far is great, but let me show the picture again. Um, we have our management network that is going over here. We have our heartbeat that is going over here. But the requirements, so I implemented some stretch clusters, and you have done the same, or you helped customers implement them. And I had some calls with the Microsoft Azure HCI support, and the guys are great, and they gave me also some additional requirements. So they said to me, and it's not in the documentation, the replica network should only be used for replication traffic. So no live migration there, so no cluster communication there, no heartbeat there. That's
Mm,
okay for me, but if I do that, we have
mm,
only our management network. So for the heartbeat, for the cluster communication. And if we
mm,
look at the live migration,
mm,
if we do live migration from node 1 to node 3, of course it will use the SMB networks, and is very fast, right? The same in this side. But
mm,
if we have to evacuate a site, because let's imagine, um, workers have to do something on your power line. So you have to shut down the power inside, in the odd side. So you
mm,
want to move your VMs from this side to the other side, and also switch the storage replication. So without any failure of your workload, and you can do that. But where should the live migration go? It should not be on these networks. These
mm,
networks can't be used because they are not connected, so it would be management.
mm,
And for some scenarios, that is right. In my scenario and in many other customer scenarios, maybe not, because this is going over the core infrastructure. And sometimes, if you do live migration, there's a lot of traffic, and you will maybe get some problems with other communication in your scenario. Same is if you move a VM that has a storage here, you move it over here, no
mm,
problem. But then every storage access has to go back here, because the replication is not shifted. And usually you have multiple VMs in the same CSV, because you can't
mm,
do more than, I would say, 32 stretched volumes in a cluster. So you have multiple VMs in your volume, and if you move one, okay, the others are still running here, but this has redirected IO over here, and that's maybe not what you want. So we need, there are other networks, of course. We need, in my opinion, an additional network where we can do all this stuff. Yeah,
mm,
and this is here. Yeah, where do we do the intersite live migration as an example? And for that, we introduce two more networks. And I know this is now even more complex, but
mm,
these networks are routed, and we can use them for our live migration between the sites. We can use it. We have another heartbeat network. It's not only going here, it's also going over these networks. at least what we want, and we will configure that. And the live migration and the cluster communication and the redirected IO. VM is running here, but the storage is still living here. So we have two powerful networks in addition to our management where we can put all this traffic.
Mhm.
So let's introduce another network called the cluster networks. And what is the purpose? Intersite heartbeat and cluster communication,
Mhm.
intersite live migration, and intersite redirected IO. And we will see all that traffic later in the video series. And maybe if you don't understand it yet or can't really grasp it, why should I do that? When we demo the stuff, you will really see the need for that. So we have two subnets with routing between the sites. That's important.
Mhm.
And because it's it can be a lot of traffic, high bandwidth traffic. Imagine our scenario. We have here a 4 node stretch cluster with NVMEs, all NVMEs. We really want that our replication is also fast because we have these fast devices. We need high bandwidth networks for that, and
Mhm.
you can't really do that with a firewall. You can't really route this high bandwidth traffic with a firewall. You should, there are some firewalls out there that can do that, but they are very, very, very expensive. So usually we would use a switch or a routing switch as the router for this network and also for the replication network.
Mm.
And
So what you're
because
saying is
it's
the inspection is just too slow, right? So
yeah,
slowing
but
down. Yeah.
firewall is most of the time also software, and it's too
Yeah.
slow. Yeah, and because of the you saw it in the documentation Bernhard showed you. The first line is RDMA is not supported if you leave the rack or the site. So these networks also can't use RDMA, unfortunately. No? So let's. This is yours, Bernhard, huh?
Yeah, I mean, it's just a summary of what we've been talking about. I won't go into the individual IP addresses or notifications, but you see that's quite a number of one stretch cluster, and you have 40 networks to care about, right?
Yeah,
And that's
it's a lot.
the complexity, or that's describing the complexity of a stretch cluster. It's the networking that you need to take care about, and
Yeah,
we need
and
to get
it's
it
no
on
fun.
yeah,
Yeah. It's
and
no
we need
fun to go to the network guys and ask for 14 subnets with
yes,
routing. So prepare that in advance.
yeah, and also the VLANs, right? So you see
Yeah,
we are using different VLANs, and we need to, we took that net numbers for our test lab, right? So we need to get this onto our physical hardware now. So let's maybe have a short look at our test lab.
yeah. So the test lab, if you watched our Azure Stack HCI installation series or our Azure Virtual Desktop on Azure Stack HCI series, you know these nodes already. This is our test cluster. There are 4 nodes.
Mhm.
Um, they are all NVMe. This is where they are. It's a bit anonymized, right? That nobody steals this fantastic hardware. No, we don't want to use other software. Um, Unfortunately, we don't have really two sites. So we
Mm.
do everything that is like in a real stretch cluster. We have switches. We are doing routing and everything, but they are together. Yeah,
They are
doesn't
in one
matter.
rack, right?
Yeah,
Yes.
they're in one rack, but it doesn't matter. It's like we really implement all requirements of the stretch cluster. So imagine the distance between the node is not 50 meters. It's very, very, very low. Yeah.
Yeah.
Um, we have two servers in each site, and we have dedicated storage and replication switches. Yeah? So it's really a setup you would do also at least on a campus cluster. And again, here's a link to our Azure Stack HCI installation series, but you will see that more often. So this is the hardware we have. This is one of those nodes, and
Hmm.
we have our BMC adapter that's used to
Hmm.
access the nodes when we don't have RDP enable and so on. Not important for us. Then we have two 100 gigabit Mellanox cards that support RDMA. Um, we have two 1 gigabit Intel buy 350 cards. We will use that in our scenario. And we have additional 225 gigabit RDMA enabled network cards from Mellanox. And what we
Mhm.
talked so far about the networks, that's the logical networks we have to present on the hardware. And we
Mhm.
will do that in the following videos. So I
Yes.
think so far, this is the
That's
end.
it for now. So thanks for staying with us because it's, I think, an important lesson. But now I think we are getting our hands a little bit dirty and trying to map these networks, the logical networks, really on the physical ones. So see you there.
Bye.